Hi, I'm Dr. Tom Field, and in this video we're going to talk about substance use. From a biopsychosocial perspective, there are strong biological, psychological, and social factors that cause the onset of substance abuse. In terms of biological, there is a strong neurophysiological explanation for adaptation, meaning the process by which a person's brain and body adapt to the initiation of a substance into the body that's external to the body. This also helps explain incentive salience. What we mean by that is a person's motivation or drive towards using the substance. In other words, they see the substance as something worth pursuing, and that happens through the process of changing the dopaminergic system, and we'll talk more about that in a minute. And then tolerance, that a person needs more of the drug to achieve the same effect. That all has a neurophysiological basis. Withdrawal, that once the drug is withdrawn, particularly if abruptly, that the person experiences rebound types of symptoms and also quite distressing and sometimes even quite dangerous withdrawal symptoms. And then craving and the need for the substance, even after the person hasn't consumed or used the substance, sometimes in years or even decades. There are also genetic influences that links to some degree, for some people, their use of substances with prior generations. From a psychological perspective, substance use can often be a coping behavior that then subsequently becomes its own problem. You also do tend to see substance use associated with risk-taking attitudes and behaviors. Those influence the substance use. So, for example, a person with bipolar disorder may be more prone to risk-taking, especially during a hypomanic or manic episode. And in those contexts, we often do see substance use. And then, of course, the social environment. So the social environment does influence use quite a bit. And so, for example, if a person is using among peers who are also using and maybe is left behind, friendship groups, maybe even partners or sometimes even family members who did not condone the use, then it's quite difficult for them to leave that environment that can feel quite supportive and to enter into a period of harm reduction or sobriety. We'll note the importance here of the 12-step movement. With that, basically, even though I don't love 12-step in a lot of ways, those types of groups, those support groups, are very helpful to create a new sense of community and are a social factor that actually is a protective factor against ongoing substance use. Okay, we're going to talk next about dopamine, and we're going to spend quite a bit of time on this because I think it does explain and help you understand why it is that a person would seek out the use of a substance over and over again, okay? And why they feel less and less in control of that over time. I'll note here at the beginning that euphoria and motivation are separate processes in drug addiction, okay? That's important because we're about to talk about dopamine, which is often associated with euphoria mostly, less about motivation. I would say actually dopamine has a lot more to do with motivation in a lot of regards in addiction processes than euphoria. Euphoria, of course, is the sense of a high, if you will. Motivation is all about reward seeking, incentive salience, that you want to pursue the use of this drug because you have enjoyed its properties, and over the time the body expects it sees it as something valuable. Okay. The graphics you see on the right-hand side, I should mention this, are interesting because it shows you that there was, I think, a photographer who had basically photographed a bunch of people who had consumed varying amounts of alcoholic drinks. And what you see in each of the photographs is what happens with a person after they've consumed 1, 2, and then 3 units of alcohol. I think these are actually glasses of wine, if I believe. And you look at these images and you think that looks like a good time, right? And it's the euphoric effect of substances that is the initial allure of them often, in addition to, for example, being able to take a person away, distract them from, move them out from things like anxiety, tension, and other distress they may be experiencing. Okay, let's talk about dopamine. So dopamine, as you remember, has a role in motor movement, motivation and reward seeking, which becomes very important to addiction processes, executive function, and positive reinforcement. Okay, related psychopathology is psychosis to high dopamine is associated with schizophrenia. Most psychotropic medications for schizophrenia reduce dopamine or block it, actually. They're antagonists. Parkinson's, too low amounts of dopamine can cause movement problems and deficits. And then you also see too low dopamine be associated with motivation, and dopamine in general be associated with addiction. To understand how dopamine is associated with addiction, we're going to now explore that a little bit through experimental studies. Okay. Now, let's begin with animals. We don't love animal studies, but there's a lot to learn from animal studies. And there have been a lot of animal studies into addiction processes. Okay. Rats that have stimulated dopamine axons in the lateral hypothalamus. Remember the hypothalamus is associated with the HPA axis. The hypothalamus sends a message to the pituitary gland and then to the adrenal glands, which are located above the kidneys. But anyway, when that happens, when the dopamine axons are stimulated, they crave food. And here's what's interesting. Even though the food they're provided has limited hedonic impact, meaning they're not being provided with a high sugar or high salt or high fat food that tastes great, that a person feels a kind of mood boost from, right? They may be chewing on lettuce, right? Something that not particularly powerful in terms of hedonic impact. In case you're interested in why certain foods have more hedonic impact than others, has a lot to do with evolutionary psychology and how things like fat stores are things that humans initially strive towards, so they would have some resources. And so a lot of foods that cause the development of fat, for example, or energy, such as sugar, are more motivating than other foods that don't have the same amount of sugar, salt, fat, those types of things. Anyway, so that's interesting, right? That a person may crave something even though the hedonic impact is not really there. So it kind of makes us question, is dopamine just about hedonism, or is it about craving, seeking? Furthermore, rats with damaged dopamine axons in the lateral hypothalamus, same area, showed a preference for food. For example, they salivated when food was placed on the tongue. They consumed the food. But interestingly enough, they would not seek food if not placed on tongue. So in other words, dopamine is very associated with seeking things out, okay? With seeking things out that are rewarding, okay? Here's another study that helps us further understand this. This is a monkey study, very famous study. The monkey basically had a electrode to the ventral tegmental area, which is a very important area in regards to the dopaminergic system. Okay, and what happens is very similar to the Pavlov experiment with the dogs, right, where the dogs were provided meat paste at the sound of the bell. The monkey at the light was provided with sugar water from a dispenser. Okay, so when the light blinked on, then the sugar water from the dispenser initially was administered to the monkey. Okay, and then what they were measuring is in the monkey the degree to which the ventral tegmental area was activated. That dopamine was released during this process. Okay, here's what they found. Before teaching the monkey that light predicted reward, what we mean by this is the monkey's just sitting there and they receive a reward, and there's no training about the light being connected with the reward. Okay, when there was no light, there was no particularly strong firing, what's called tonic firing, which is regular type of firing. The phasic spike is what we're looking for with the release of dopamine. What happened is after reward, like after the sugar water, the monkey had a spike in dopamine. It's interesting to note here that the spike in dopamine initially occurs afterwards, after the reward. The reason this is important is we're starting to learn. We're starting to learn that, oh, actually the sugar water was nice. I do like that. And I'm going to seek that out. Okay? So dopamine initially increases after the consumption of something. Think about this with drug use. That a person may, for example, use something like cocaine, nicotine, alcohol, whatever, And after the first dose of it, there's a spike of dopamine after that, because then we learn, oh, this is actually something that I like, that I want to seek out. Here's what's interesting. When teaching the monkey that light predicts reward, so at this point they're into the training phase, and the monkey's been taught that when the light comes on, you get the sugar water. Okay. After a while, this is what happens. The reward is predicted, and the big phasic spike, which was bigger than before, okay, which is a larger spike than you saw after the sugar water was first administered, is bigger at seeing the light. And here's what's super interesting. When the actual reward was provided, which you see there happens quite a bit later, there's no spike of dopamine. So in other words, dopamine is all about the expectation, right? The seeking and the expectation of reward, not really so much about the hedonistic property of the drug or of the sugar water, okay? So, and here's what's very interesting. This is what happens when a reward is predicted and no reward occurs. You still see, when the light comes on, the dopamine spike. And there's no reward, and so there's no particular spike afterwards, of course, and there isn't anyway, even if when the reward is provided. So in other words, the anticipation of reward provides you with incentive to go seek it out, even if you don't receive a reward. This helps us understand things like process addictions like gambling, and why people continue to gamble even if they've lost over and over and over again, because the dopamine spike is still occurring every time the person starts to gamble. Even if they lose, it's not the loss that is motivating, it's the seeking, if that makes sense, seeking of the reward. It's the same thing with drug addiction, that it's the seeking, that aspect that really is part of the big dopamine spike. If you actually read a lot of memoirs of people who have recovered from and enter into recovery for substance use, a large portion of their narratives is all about seeking the substance. So now that you understand what dopamine is about reward seeking primarily, let's take a very quick look at dopamine projection pathways in the brain to understand what is happening at the neuro level. Okay? So we talked about the VTA before with the monkey study, the ventral tegmental area, see that in the bottom right there, as well as the substantia nigra. Those two areas are primary dopamine producers in the brain. Okay, they produce and secrete dopamine. The blue pathways that you see there are the major pathways in which dopamine is sent around. Okay, and there's a mesocortical pathway, and there's the mesolimbic pathway. And as you might imagine, the mesocortical pathway basically extends around the cortex. Okay, it's kind of the longest pathway you see there. And then the mesolimbic pathway is the one that extends into the limbic area, which you can kind of see there as well. It's important to note here that these two pathways do different things. Okay, let's look at the mesocorticalimbic projection. We'll start first with mesolimbic and then look at mesocortical. This has to do with decision-making first. Let's talk about decision-making related to these two pathways. The mesolimbic pathway, remember that's the one that's activating or sending dopamine to, I should say, the limbic structure, such as the hypothalamus, but also hippocampus, amygdala, thalamus. So dopamine from the ventral tegmental area, VTA, and ventral striatum is sent to the limbic region, including the nucleus accumbens. You may remember that being associated with the basal ganglia. That's associated with motivation to seek hedonic properties of the drug, okay? And releases dopamine in anticipation of the substance, just as you saw in the monkey study. The mesocortical area has a different kind of feature. Dopamine is sent from the ventral tegmental area to the prefrontal cortex this time, not to the limbic area. And as you might imagine, decision-making and planned behavior around the use of the drug occurs. So in other words, a person gets excited, gets motivated by the anticipation of the substance, and then they start to organize behavior around getting the drug, getting the substance. Okay, and the second pathway, this is the nigrostriatal projection, which I didn't refer to in the image, but you can go back and look at that if you're interested. This is about learned associations. What's interesting here is that the brain also remembers situations when drug use occurs and predicts reward in those situations. So for example, going to the same bar or going to a neighborhood in which you've scored drugs before, there is a large amount of anticipation of dopamine released around those situations, okay, because of learning. In addition to those processes, the insula has quite an important role here, as well as the amygdala. The insula relies on interceptive cues for reward prediction, such as dopamine, excitement, and tends to choose smaller, sooner rewards. What we mean by that is the insula becomes kind of attenuated or attuned to this idea that it's better to seek the immediate gratification because it's so rewarding versus waiting, or postponing reward for a longer term benefit, such as maybe improving your relationships, right? Or maintaining your job. Those things are pushed aside so that short-term rewards take priority, such as substance use. Same thing happens in the amygdala. There's a preference for immediate rewards, and it interrupts top-down appraisal of long-term consequences by the ventral medial prefrontal cortex. So in other words, just to summarize so far, a person is really shaped a bit in terms of their preferences. Their preferences towards short-term, more instant rewards, even at the expense of long-term consequences, such as impairing relationships, jobs. And there's a large focus about within the brain about predicting reward and seeking that reward. And that seeking process is quite motivating, even if the substance itself is not motivating. This becomes important later on when we talk about the kind of flow and progression of addiction, which is after a while, the person isn't using to chase the high anymore. They're using for other reasons. So let's talk about neuroadaptation now that we've learned some basics about brain anatomy with addiction. This is a study about the administration of cocaine to monkeys. What you see here is that exposure to a single low dose of cocaine made the monkeys' brains less responsive to the subsequent dose of the drug taken thereafter. And so that is what we refer to as tolerance, that you need more of the drug to achieve the same effect. Blue is dose 1, and this is dopamine response, and red is dose 2. Okay, so it's interesting, right? And as we saw before, what's notable is that the dopamine spike is occurring, of course, after use here. But we also know that the dopamine spike kind of changes in its phasing, if you will, of when it's occurring. It usually starts to occur actually before use because it's all about seeking it out. So let's take a look at what's going on here, right, for all these changes to take place in the brain. There's a very interesting finding in the last 20 years about these early genes that are causing these changes to brain processes. Jun and FOS, particularly delta FOS-B, are things we're going to talk about. Why these are so important is they cause modifications to dendritic spines that are linked to the dopamine pathway, and this results in increased sensitization and salience for the drug. In other words, the brain expects, right? If you have a ton of receptors on the dendrites, and they all expect a certain amount of the drug, okay, then the brain is going to not like it when it's not provided. Let me try to explain that. The brain does not like abrupt change, okay? So if you're going to, for example, start taking a large amount of cocaine each and every day, it doesn't take that long, but after maybe a week, maybe less, all of a sudden the brain realizes, all of this cocaine, I'm going to adjust to that. So I'm going to make sure I have all the receptors to receive that extra dopamine and norepinephrine. And I expect that each and every day because this drug has been taken, on a chronic kind of basis. Remember that addiction doesn't really occur if a person is using a drug once a month, right? Addiction occurs with chronic, ongoing, persisting use because of neuroadaptation. And so what happens when the drug isn't received after, say, a month of use is that all of a sudden those receptors are thrown off, right? They're dysregulated. They're like, well, where is this all these extra neurotransmitters that I'm used to, right? And so the person starts to experience side effects related to that. Note that these changes are not permanent, encouragingly. Delta FOS-B concentrations are not found 1 to 2 months after withdrawal. So in other words, you do see those dendrites and receptors eventually return back to their normal form and not be quite as expansive. Here's a visual, it's kind of a pop culture type visual, but it hopefully helps you understand what's going on here. You have basically a growth factor protein that's being administered, and delta phos B in this case, immediate early genes. And what you're seeing happen here is that the neuron, the dendrites, become a lot more numerous, and the receptors become a lot more numerous. So, as I've mentioned, dendritic receptors are more numerous, and the brain expects the same amount, and because homeostasis has been adjusted, which also reduces the hedonic properties as well, right, over time. Stopping or reducing intake results in dysregulation, particularly to things like the HPA axis. Okay, there are often rebound effects, and you see things like increased anxiety with alcohol, increased panic, and discontinuation syndromes with SSRIs, with opioids, increased physical pain. Now, what's going on here? Well, what's interesting is the reason that the kind of the positive, if you will, effects of these drugs in the first place are reversed when you stop taking the drug. So, for example, alcohol, we know that has an impact on GABA, right? It increases GABA, which is an inhibitory neurotransmitter. If the brain expects a large amount of GABA and you stop that abruptly, all of a sudden you're going to have a very large amount of anxiety, much more than you had initially, believe it or not, because again, the brain expects. Same thing with opioids. That's why a person can be in quite significant physical pain after they stop using things like heroin. I mentioned that there is a change to addiction processes that occurs over time, and that a person still seeks out a drug even if they are not receiving the hedonic properties of the drug. Okay, initially drugs are primarily used for their desired properties, such as the hedonic properties, as well as, as I mentioned, trying to mask over negative emotions. That salience leads to wanting and later to craving, but then motivation shifts from positive to negative reinforcement. Let's talk about what positive reinforcement means here. It's about addition, right? So if a person, for example, seeks out a drug, they consume the drug, and they receive a positive effect from it, then they're going to keep doing it through positive reinforcement. Okay, what happens though over time is negative reinforcement, which is that, and you read this again a lot in if you read narratives of people who have come out of addiction, or if you interview someone who's been through addiction, they'll say things like, I wasn't using the substance to get high really anymore. I was using the substance because I didn't want to experience withdrawal, right? I wanted to, quote, get healthy, right? I didn't want to be someone who, and that's a term used by people with substance use, I didn't want to feel like I was going to go through the nightmares of withdrawals. And so the person is using primarily just to stop the withdrawal process, right? And that's unfortunate, of course, because drug use is just very, drug use, I should say, is is problematic in that way. It's something that is misunderstood. I think we think of people as having impulse control problems and being unable to stop. Well, the truth is, a lot of people in the throes of addiction may want to stop, but they fear stopping because of the effects of stopping. I'm going to skip these pieces here and move to this. Okay, the diagnosis of substance use. So far we've talked about some vague kinds of definitions of drug addiction, that it's chronic and progressive, right? That a person has to persist with drug use over time to develop an addiction. For example, one-time use each month is not going to lead to an addiction. That the person feels compulsion to consume the desired drug, right? That they are highly motivated through the dopaminergic system at the expense of other reinforcers, right? Such as things like other relationships, work, jobs, and also physical safety, right? That a person may be willing to place their physical well-being at risk through things like, dangerous injections of drugs, or being in neighborhoods that are unsafe in order to pursue use of drugs, driving under the influence, things like that. Okay, so let's look at the formal definition now of substance use disorders in the DSM. Okay, so a substance use disorder is at least two of the following in the past 12 months. Okay, And actually, all of these should count. I don't know why there's some sub-bullets there. Substance taken in larger amounts or over a longer time period than intended. A persistent desire or unsuccessful efforts to curb use, right? The person has tried to stop unsuccessfully. It's the use subsumes a large amount of time, and the use includes, of course, obtaining the substance, using it, and recovering from using it. The person experiences craving or strong urges. They may be failing obligations at work, school, or home. They use despite social or interpersonal problems, and activities are given up or reduced. They may use in physically hazardous situations. They may use despite knowing it exacerbates problems, and tolerance and withdrawal can occur. Specifiers here are mild, moderate, and severe depending on the number of symptoms that a person has. A person can have a fairly mild substance use disorder where, for example, they may be spending a large amount of time using, but they're not yet failing obligations. They're fairly functional, if you will, and they aren't experiencing things like tolerance or withdrawal yet. They haven't used it for that long enough to have that type of symptom. Or you can have people who've been using a substance for 10 or longer years, and they may have most or even all of these symptoms. Substance use is differentiated from substance intoxication, which is classified as recent use of a substance that is associated with clinically significant behavioral or psychological changes, which of course varies between substances. And of course, signs and symptoms vary between. So why would you diagnose substance intoxication? Typically, if a client shows up to your session drunk or high, you're probably not going to diagnose that right off the bat, but you are going to monitor it. This would be used for something like an inpatient stay, whereby a person has, let's say, a very significant impairment from intoxication. It could be something like recent PCP use. I've seen stuff like that, whereby a person is really quite impaired because of that. So it could be something like that you would code this. If a person has the two or more of the symptoms we've just kind of discovered on the slide previously around substance use, you would probably be coding this as substance use disorder. So it depends how frequently this intoxication has occurred. And then you also have substance withdrawal, which is cessation of heavy and prolonged use and symptoms resulting from cessation that cause distress or impairment. Your specifier can include with perceptual disturbances, but you have to rule out delirium first, which we haven't learned about yet. We'll learn about that in the next video lecture. Why, again, would you diagnose substance withdrawal? Substance withdrawal would be diagnosed if a person is being medically managed on a detox unit and they're not, they don't have a substance use disorder perhaps currently, but maybe they just need, the coding is more appropriate for withdrawal. Most of the time, a person is going to have a substance use disorder diagnosis, though, even if they're in treatment. I want to talk just briefly about what happens within the brain with long-term substance use. Some of this stuff is pretty frightening, but important you understand. So let's take a look at alcohol. Alcohol, of course, if you think about things like but very high volume, high concentration alcohol, right? Rubbing alcohol, for example. If you consume that, that's quite toxic, right? Fairly low alcoholic volume beverages are not nearly as toxic, but what happens though over the course of time is that while they may not be toxic initially, there are actually quite some toxic effects with the use of alcohol. So take a look at the two images here. On the left-hand side, you have a control brain on the bottom, and on the top you have a person who has been using alcohol. You'll notice huge differences in the person with alcoholic use in terms of these large black areas, these large black gaps. You may remember, and I think in the very first video lecture, we talked, maybe it's the second one, we talked about the nervous system. We talked about the ventricles. And that, remember, are these naturally occurring spaces, gaps within the brain that are filled with cerebrospinal fluid. Well, what happens over time when there is volumetric change and decline, meaning that there are the death of neurons and the shrinkage of brain areas, is that these ventricles increase in size. And so you can see in the person with alcohol there, those ventricles have grown quite large because the brain has shrunk in size. Okay? Same thing on the right-hand side. When you compare the ventricles of a person who has and has not had a chronic alcohol problem, they're quite significantly different. And so we associate this, unfortunately, with quite significant symptoms as well. You can see memory problems, attentional problems associated with this, right? Emotional regulation difficulties. And those difficulties, unfortunately, are quite difficult to correct. In fact, if a person has chronic alcohol use and they enter into remission, it's pretty likely that while they may be able to repair some of this, that some of this may not be repairable. This is another example. Yet one more example. Interestingly enough, when you compare people who are younger versus older, who have been using alcohol for, chronically, and you look at gray matter volumes, remember gray matter has to do with new neurons that have not been myelinated yet. What you tend to see is that there are much larger differences in people who are older, right? That over time you're not seeing the growth of new neurons in the same way that you would with people who are younger and haven't been using for as long. And you see this across all domains of the brain. That's another thing that's really notable here, right? In the prefrontal area, the frontal area, anterior, posterior area, right? In temporal, parietal, occipital, all of these areas, right? In all of the major lobes of the brain, you see these differences. So we want to obviously try to intervene, right, before a person's substance use really becomes quite impairing, and a person, for example, becomes at risk of things like a neurocognitive disorder, like Alzheimer's. You're going to be at increased risk of that if you consume alcohol like this, because as you'll see when we learn about neurocognitive disorders, you also tend to see, unfortunately, volumetric decline in neurocognitive disorders as well, quite similarly. So prevention looks like, if you can, during the intoxication stage, trying to help a person move away from chronic ongoing use, right? If you can intervene earlier, that a person isn't so deep into the addiction, you're probably going to have either more success, or it would be easier for the person to enter into a state of recovery. Education about substances and their impact on the mind and body and legal issues can be helpful. Maybe, for example, adolescents and young adults don't understand these things. Of course, things like the DARE program are known to be ineffective. So you don't want to necessarily go about this in a kind of scare tactic approach, but maybe some degree of information about things like why it is that you seek out this substance now, and why you'll continue to do that even when the rewards decline. Family therapy can be useful in cases of adolescent use, particularly if there is substance use in the home. And then, of course, discussion about the social environment. Who are you using around or drinking around? And is there a way for you to consider leaving those social situations where you know you're going to be more prone to use? In terms of intervention or treatment, clients will use despite the consequences, and so just providing a cogent rationale is not the answer here. The new approach is motivational interviewing at first, following by CBT for craving and relapse prevention. That is proved by SAMHSA. It's one of the interventions known to be successful. Motivational interviewing is helpful just to help a person really play through their own motivations for curbing use or reducing use. And then once they've reached the place where they're ready to make changes, then you would use CBT to help them through craving and relapse prevention, which can be quite notable and challenging. The old approach, of course, is confronting denial, which we know is not particularly effective. And the reason for that is, of course, people really aren't going to respond well, especially when they're going to use despite the consequences, to the idea of just being confronted about their own use. One other thing that's worth mentioning here, which is that substance use in a lot of traditional models has really tried to, in substance use treatment programs, have really tried to apply the abstinence model. The abstinence model is that you cannot use the substance at all and need to enter into complete and total sobriety. Okay. Now, the problem with the abstinence model is it doesn't work for all clients. Some clients do a lot better with what's called a harm reduction model, which is just reducing the amount that a person is using to a manageable amount. And a lot of treatment programs, unfortunately, do not offer this. That's not part of their treatment. It's a good example of this. They'll do things like run urinalyses or urine drug screens or drug tests as part of treatment. And if there's a positive drug screen, that means the person has relapsed. Well, I think that's a bit unfair, and it certainly is contrary to a harm reduction model when the person may not be trying to completely quit anyway. That's not the goal of treatment. I will also add, though, and this is very important you understand, harm reduction does not work for everyone. There are some clients who will need more of your kind of abstinence model because they really are unable to regulate the amount of use. Oh, well, there you go. I kind of talked about that too, didn't I? Okay, we have to talk about process addictions a little bit. There's actually only one process addiction in the DSM-5. Other process addictions that were considered but never made it are things like sexual addiction. Non-suicidal self-injury was also proposed but didn't make it in. So let's just, and also I would add things like internet addiction, video game addiction, I think are going to be considered in the future would be my guess. So let's just focus on gambling disorder. If the others do make it in, they'll have a similar flavor, theme to gambling disorder. So you need at least four of the following symptoms in 12 months. A need to increase amounts spent on gambling to get the same excitement. Feeling restless or irritable when cutting down. Repeated unsuccessful efforts to stop. Preoccupation with gambling. Gambling when feeling distressed. Chasing one's losses, for example, returning after losing money the next day. Lying to conceal the extent of involvement. Having jeopardized or lost significant relationships, jobs, or opportunities because of gambling. Relying on others to relieve financial burden of gambling. And this gambling is not better explained by a manic episode. It's important to mention this because, of course, reckless spending can be part of mania. And the specifiers are episodic or persistent, and then, again, just like substance use disorder, the number of symptoms present, which differentiates mild from moderate to severe. One other piece to mention about these symptoms listed here is that the same dopaminergic system is online, right? Is being kind of changed through the gambling, ongoing gambling, right? Which is the person is seeking it out over time, even if they're not receiving the same rewards. In conclusion, substance use disorders have a strong neurophysiological foundation. The brain learns and adapts to the environment and to new chemicals that enter the body. And over time, that leads to tolerance and eventually withdrawal. While some people with substance use disorders claim that one-time use leads to addiction, physiological addiction is caused by repeated use over time. Okay? We should also note that long-term chronic and excessive use of alcohol can cause volumetric change. This is true for other substances too. I just listed alcohol here just because I thought it was helpful just to pick one and talk about it. You should also know that motivational systems are directed towards prioritizing substance use, the dopaminergic system. And because of this, motivational interviewing is often a first step, followed by CBT for craving and relapse prevention. And one last piece, because of our biopsychosocial model, we should also know that we should attend to a person's social environment and try our best, if we can, to move a person away from communities in which there is heavy substance use, because it's very unlikely they're going to be able to curb use because of just social influence. And that wraps up this video lecture.